All right, everybody, welcome to 2.4. This is the quadratic formula, and it is something you've seen before. We are going to really focus on the quadratic formula when there's some negatives where we don't always like them. So when we're talking about quadratic formula, we're talking about squares. Quadratic equation, y equals x squared. So perfect squares. Are these numbers here? Why are they in that order? I didn't do this. This is random. Anyway, the perfect squares are, this is wrong. This should say 6 squared. Okay, so the perfect squares are a whole number squared. And I know you know these numbers, and we need to know them really, really well. Okay, we need to know them really, really well. When you see a number that is a perfect square, you really, really, really want to recognize it as a perfect square. So get used to those numbers, memorize them, especially the ones that are over 10 squared, because we are going to use those a lot. Okay, we will use those an awful lot. So here's how this works. To simplify the radicals. A radical is totally simplified when no perfect square factors exist under the square root sign. So to simplify this, we look for a perfect square that is a factor of 18. For example, 1. Okay, the perfect square that divides into 18 is 9. So we rewrite this as the square root of 9 times the square root of 2. 9 times 2 being 18, 9 being a perfect square. The square root of 9 is 3. Notice the square root sign goes away. Square root 2 stays as square root 2, and this is your simplified answer. The number under the radical does not have any perfect square factors. Okay, now when you saw 18 and you were looking for factors of 18, if you thought 6 times 3, that does equal 18. So square root 6 times square root 3 does equal 18, but we can't take the square root of 6 and we can't take the square root of 3. Those are not whole numbers. They have square roots, they're just not whole numbers. So that pair of factors won't work for simplifying radicals. So let's look at example 2. Square root of 90. We want a perfect square that is a factor of 90. Okay, that is 9. Square root of 9 times square root of 10. Square root of 9 is 3. 10 is not a perfect square, and it does not have a factor that is a perfect square. So 3 times square root 10 is our simplified radical form. Notice that is a times. Okay, that does mean multiply. We don't always write the multiply there, but it means multiply. So let's look at example 3. We have 75. The perfect square that divides into 75 is 25. Square root 25 times square root 3. 25 times 3 gives us 75. 25 is a perfect square. So square root of 25 is 5. So this simplifies to be 5 times square root 3. We can't simplify that square root 3 any further, so it stays. Okay. 4 looks like a big, huge number to 88 until you realize that, well, half of that is 144, and that's 12 squared. So this is square root of 144 times square root of 2. Square root of 144 is 12. Leave that 2 under the square root. 12 square root 2 is our simplified form. So notice in all of these that when we have the perfect square under the square root and we take the square root symbol disappears. We did the square root, so the symbol is not there anymore. Okay? Now, let's talk about some imaginary numbers. Imaginary numbers. They're not real, but we don't call them fake. We call them imaginary. Imaginary number is the square root of a negative number. Specifically, we use I to represent the square root of -1. Okay? Imaginary numbers can be written as b times I, where b is a real number, I is the imaginary unit. Okay, so if we take a look at a few details here, to do the square root of -2, to take the square root of -2, we factor out the square root of -1. Square root of -1 times the square root of 2. That square root of -1 becomes the I. And that square root 2 stays as a square root 2. If we do square root of -4, factor out a -1, so square root -1 times square root of 4. Well, the square root of 4 is 2, and that I is the square root of -1. Now, a very unique fact that we'll use a lot, if we take the square root of any number and we square it, we get what was under the radical. So I would have put this in the other order. I would have said the square root of -1 all squared. The square and square root undo each other. Okay, that is -1. Well, the square root of -1 can also be written as I. So I squared equals -1. I squared equaling -1 is a factoid that's going to get used a lot. I squared equals -1. Okay, so let's look at how to simplify some of these radicals with a negative. We have the square root of -9. We're not just going to stop and say you can't take the square root of a negative number, because you actually can. It's just imaginary. What we do is factor out the square root of -1. So square root of -1 times the square root of 9. So the square root of -1 we write as I. Square root of 9 is 3. And we write this in BI form. So we will write this as 3I. So let's look at example 6. 3I squared. When we square something, we're squaring the 3, we're squaring the I. That's a multiply, so we really do just square both of those. 3 squared is 9. I squared from over here is -1. Okay, so this equals -9. 3I in parentheses squared is equal to -9. Okay, I squared converts to -1. Okay, now my page right here might be in a little bit different order than your page. I'm going to try to do it in the order of your page. So I'm pretty sure example 1 is what's next on your page. But anyway, this is where we're going, where it says example 1, 2 times square root of -64. This coefficient 2 acts like a coefficient of a term. This coefficient 2 stays. The square root of a negative, factor out that negative. So we'll factor out that -1. That leaves the square root 64. Well, the 2 is a multiplier. All this is multiplied. The square root of -1 is I. Square root of 64 is 8. Multiply 2 times 8. This is 16I. So 2 square root -64 simplifies to 16 times I, or just 16I. Now, let's look at one that's a little more complex. Let's look at example 2. We have the square root of 4 squared minus 4 times 4 times 4. Okay, and if you're thinking that pattern looks a little familiar, we're gonna see this here in just a minute. So order of operations, okay, order of operations, square that 4 first, so 16, then minus, multiply 4 times 4 times 4 is 64. So this ends up being the square root of -48. Now, when we factor this, we need to factor out the square root of -1 times square root of 48. Now, to simplify this, again, we need a perfect square factor that divides into this 48. Now, we want to find the largest perfect square factor that divides into 48. So, the square root of, wrong pen, the square root of -1 stays. We break square root 48 into square root 16 times square root 3. 16 being the largest perfect square that is a factor of 48. So, the square root of -1 is I. Square root of 16 is 4. That square root of 3 stays. So we will write this as 4i square root 3. We do the number, then the variable, standard order, what colors am I using? And then we put the radicals at the end. So 4i square root 3 is how you will see this answer. Now, let's take a look at example 3. If you're looking at this format and going, man, that's something. That format's something special. It is. We'll get to it in about after this problem. So, let's take a look at this. That we need to simplify the radical. 2 squared is 4. 4 times 8. 4 times 8 is 32. So, this becomes -2 plus or minus the square root of -28 all over 16. 2 times 8. Okay, now simplify this again. We need to simplify that square root of -28. It's going to be -2 plus or minus. We factor out the square root of -1. And then think about that 28. 28 has a perfect square factor of 4. So square root 4 times square root 7. 4 times 7 giving us the 28. The square root of -1 factored out. And there's our 16. Now, keep simplifying. -2 plus or minus. The square root of -1 is I. The square root of 4 is 2. We leave that 7 under the square root sign. And we divide by 16. Now, if you look at all of those numbers, the 2, the 16, realize we can divide each of those terms by 2. So we do need to do that to be completely simplified. So this becomes -1 plus or minus I square root 7 all over 8. This is your final answer. Now, if you're looking at this and going, I know I've seen this somewhere. Miss Seifert, just tell me where I've seen it before. Okay, I'm going to tell you where you've seen it before now. This is in the format of what we call the quadratic formula. Okay, the quadratic formula does this. When ax squared plus bx plus c equals 0. You might see it as a y equals instead of an equals 0. To solve that, we can plug it into the quadratic formula. And the quadratic formula is -b plus or minus the square root of b squared minus 4ac, go ahead and put that b in parentheses, all over 2 times a. That is the quadratic formula. A, b, and c being the coefficients and constants in the equation. Now, some of those solutions will be real numbers. Some of those solutions may be imaginary numbers, like what we've been working with. They may be complex. Complex numbers have a real part and an imaginary part. So it's kind of like a combo of real and imaginary. It would be a lot like example 3. Example 3 is complex. It has part real and part imaginary. Another way you might see the answer for 3 is in 2 separate terms, -1 over 8 plus or minus I square root 7 over 8. That is another way you might see that answer, and that's in what we call complex form. Sometimes referred to as A plus BI. A being a real number plus or minus the imaginary term. Okay. Now, quadratic formula is not something that college readiness tests, SAT, PSAT, ACT tend to give you. Okay, you do need to know the quadratic formula. Watch that negative sign in the front. Watch the b squared. Don't forget all those little parts. So, let's work some problems. And let's find these zeros. Okay, let's find these zeros. If you want that quadratic formula on this page, x equals negative b plus or minus square root of, put the b in parentheses, put the square on the outside, minus 4ac, all of that's under the radical, then both of these terms get divided by 2a. Okay, so on example 1, a is 3, the coefficient of x squared. B is negative 4, the coefficient of x. C is negative 1, the constant. So, as we plug into the formula, it starts with the negative of b. Our b is already negative, so negative of negative is positive 4, plus or minus the square root of b squared. Be really careful here. We're squaring all of negative 4. Minus 4 from the formula times a, which is 3, times c, which is negative 1. B squared minus 4 times a times c, and we divide all of that by 2a, 2 times 3. Okay, so simplifying this, 4 plus or minus the square root of 4 all squared is 16, minus a minus is plus 12. So that's going to be the square root of 28. 16 plus 12, 28, all over 6. Now, simplify that 28. We get 4 plus or minus square root 4, square root 7, all over 6. Then 4 plus or minus the square root of 4 is 2, square root 7, all over 6. And you're looking at this and going, whoosh, we're done. Okay, not quite, sorry. Each of these terms will divide by 2, so we do need to take it one step further. So then that's 2 plus or minus the square root of 7 all over 3. And this is our simplified solution. Realize that does represent two values of x. One's the plus, one's the minus. Now, let's look at example 2. Example 2 is a little different. For starters, it's not quadratic. It has x to the third as its highest power. So quadratic formula is not the first method we want to look at to solve this. But remember, we're treating this like they equal 0 because that's what we're solving for. Okay, if you remember from a couple lessons ago, we can factor this. So factor out an x, then x squared plus 9 is what's in parentheses. That's equal to 0. So setting each factor equal to 0, x equals 0 is one solution. Then x squared plus 9 equals 0. Solving that will get us the other solution. So x squared is equal to negative 9. So x would equal the square root of negative 9. To do the square root of negative 9, we think square root negative 1 factored out times square root of 9. So x equals 3i. And because we did take the square root, there is a plus or minus on this. So plus or minus 3i is a pair of imaginary solutions. X equals 0 is a real solution. So there are 3 solutions here. 3 solutions here, 1 real and 2 imaginary solutions. So in this case, we didn't need the quadratic formula. X squared plus 9 was quadratic, is quadratic, but because the only x term is the x squared term, we can just isolate it and take the square root of both sides in order to solve. We called that the square root method a couple lessons ago. So let's look at example 3. Okay, example 3, we have t's instead of x's. Don't let that throw you. You can convert them to x's if you want to. I won't be mad, I promise. So take a look. It's not a color that's going to show up. Take a look at this one. Okay, there's only 2 terms, and it's x to the third, or t to the third. So we can't really use quadratic formula here, at least not yet. So it's got a common factor of 2t. So factor out that 2t, and we get t squared minus 20. We're solving this for the zeros. We can factor this one and solve it very similarly to what we did in example 2. So 2t equals 0. T equals 0. 0 divided by anything is 0. Then t squared minus 20 would equal 0. T squared equals 20. So t equals the square root of 20. And since we took the square root to solve, we need a plus or minus there. Okay, take that square root of 20, find a perfect square factor. It's 4. 4 times 5 is what gives us 20. So square root 4 times square root 5. Then t will equal plus or minus 2 square root 5. And t equals 0 are the solutions. Okay. Now, this is 3 solutions. They are all real solutions. 2 square root 5 is real. There's not an I. There was no negative under the square root sign. It's irrational, meaning it's a never-ending decimal, but it's still real. So this is 3 real solutions. So let's check out example 4. Okay, we check out example 4. Okay, we notice we have an x in every single term. So to work with that, we're going to factor out that x. We'll have 10x squared plus 7x plus 4. And we want to solve this. So x equals 0 is going to be one of those solutions. Okay, 10x squared plus 7x plus 4. I'm going to come over to the side and see if this will factor. It may not. I don't know yet. But if it will, it'll be easier to solve with factoring. We would need 3 terms. So it's going to be a product of 10 times 4, which is 40, and a sum of 7. So 1 times 40, not the right sum. 2 times 20, not the right sum. 4 times 10, not the right sum. 5 times 8, not the right sum. This isn't going to factor. Okay, but it was worth checking. It's worth checking, not going to factor, other than factoring out the x. So what we need to do from here to solve the rest of this is use quadratic formula on the quadratic part. So that a is 10, that b is 7, that c is 4, and we want to plug into, again, the quadratic formula. So x will equal negative b, so negative 7, plus or minus the square root of b squared, 7 squared, minus 4 times a is 10 times c is 4, all over 2 times a, 2 times 10. Okay, so simplifying this, negative 7 plus or minus square root of 7 squared is 49 minus 4 times 4, 16 times 10, 160. So that is going to be the square root of negative 119 all over 20. Okay, now negative 119. We need to split off that negative. This is negative 7 plus or minus I, square root of 119, all over 20. Okay? Now, 119 won't simplify. There are no perfect squares that are factors of 119. So x equaling this is part of the solution. X equals 0 is part of the solution. This is 3 solutions. And again, it's 1 real and 2 imaginary solutions. The I giving us the imaginary part. Okay. All right. You pause this video. You try these last 2 problems and start the video again and see how you did. So pause. You're back. Did you really do the problems? Give them a try if you didn't. Pause. Okay, let's take a look at this first try problem. It has 3 terms and it is quadratic. It's worth seeing if the problem will factor. So with 3 terms, we look for that sum and product. The product would need to be 4. The sum would need to be negative 1. So we'd have 1 times 4 or 2 times 2 for factors of 4. To multiply to be a positive 4, we need both signs the same. To sum to be a negative, they would both have to be negative. Well, none of those add up to negative 1, so this won't factor. So we do need to go to quadratic formula. So x equals negative b, that's going to be a positive 1, plus or minus square root of b squared, it's negative 1 squared, minus 4 times a, 2, times c, 2, all over 2 times a, another 2. Lots of 2's in here. Don't get too lost in those. 2 lost. Okay. All right. So 1 plus or minus the square root of 1 minus 4 times 2 times 2 is 16. 1 minus 16 is negative 15. All that is over 4. Okay, that negative 15, we need to factor out the negative 1. And 15 does not have any perfect square factors. So x will equal 1 plus or minus I square root of 15 all over 4. This is 2 solutions. This is 2 solutions. They're both imaginary. 2 imaginary solutions. All right, and on this last one, hopefully when you looked at this problem, you recognize it's not actually quadratic. It's not actually quadratic. And I hope you noticed the greatest common factor, not just with the variable, but with the numbers. So if we factor out a 2x first, this will work better. Because we can't use quadratic formula unless we actually have a quadratic. So dividing out that 2x, we get 3x squared plus 5x plus 12. Okay, it is worth a quick check to see if this would factor. We would need a product of 36, 3 times 12. We need a sum of 5. This isn't looking really likely, is it? 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. None of those add up to a positive 5 and multiply to a positive 36. 4 and 9 look good, but to multiply to be a positive 36 and add up to be a positive 5, all the terms would have to be positive. So no luck factoring. Okay, this is when we go to the quadratic formula. Now, don't forget 2x is equal to 0. x equals 0 is going to be one of the solutions. That greatest common factor, has an x in it, so it does affect the solution. Now, solving the quadratic on the inside, x equals negative b, so negative 5, plus or minus square root of 5 squared minus 4 times 3 times 12, all over 2 times a, which is 3. So x equals negative 5 plus or minus square root of, that's going to be 25 minus 12 times 12, so 144. 25 minus 144, this is negative 119, and all this is divided by 6. Now, negative 119 under that radical, we need to factor out that I. So negative 5 plus or minus I, square root of 119, all over 6. Square root of 119 will not factor any further. X equals 0 was one solution. And x equals negative 5 plus or minus I square root 119 all over 6 is 2 more solutions. So this is one real. Keep doing that in the wrong pen. So this is one real and 2 imaginary solutions. One real and 2 imaginary solutions. All right, guys, that is it for 2.4. Bye, y'all.